2.2 is what we're going to go over today. Okay, so 2.2 is trying to get you to associate ordered pairs, which we learned about in 2.1, and equations. And they say a solution to an equation with two variables is an ordered pair, x comma y, that makes the equation true. And so true for an equation, remember, means the left side and the right side are equal to one another. So we can test whether or not these things are solutions by plugging in. Now, by virtue of being first, they're telling this is x and this is y, by virtue of being second. And then you would do substitution, 3, and then instead of x, we'll put the parentheses every time you substitute, and y equals 21. And they told us 0 for x and 3 for y. And so you notice that that's 0 plus 21 is 21. So 21 equals 21. And so what that tells us is that 0, 3 is a solution. Seven, 0, so same thought, x, y, and 3 times x plus 7 times y equals 21. So we're putting in for x 0, 0, 7, and for y 0. So this is 21 equals 21. So that tells us 7, 0 is a solution. And then 1, 2, they're asking me, hey, is that a solution? So I'm going to plug in, this is x, this is y, 3 times 1, right, plus 7 times 2. And knowing the others are solutions doesn't tell me anything about this one, so I don't know until I do the arithmetic to see. So that's 3 plus 14, and that's 17, and that doesn't equal 21. So what that tells us is that 1, 2 is not a solution. Now I admit in the back of the book that they just list the ones that are solutions. So they list this one and this one because they're solutions and don't list that one. But I wanted to write what we found so that make sure that we knew. Now what they're trying to get us to do is they're asking us to complete a solution. So they gave us part of a solution and asked us to find the other part. And so this has two variables in it. And if I tell you what one of the variables is, then you can use arithmetic or math, maybe a little algebra to find the other. So here they're saying x is 0. So I'll plug that in. Y equals 3 times x, which they said was 0. And all I have to do to find y, I don't have to do any algebra at all. All I have to do is arithmetic. 3 times 0 is 0 minus 5. So y equals negative 5. And I'm going to put that in the y spot right here. In the back of the book, they just say negative 5 because that's what they've asked you for. But it's creating the ordered pair 0, negative 5 is what it's creating. And then here, you notice they don't tell me the x-coordinate, but they tell me the y-coordinate is 13. And so when I go to plug this in, I'm going to have 3 x is unknown minus 5, right? But 13 for y. And you could put it in parentheses, but it's not necessary. Here it was necessary because something else was happening with it. And so I get where, I say put parentheses every single time when you're replacing, but I have to admit that, well, if they're totally not necessary. Now, x is not just a matter of doing arithmetic to solve for x. I have to do algebra. I have to do the thing that we were learning in chapter 2. Oh, this is chapter 2. Chapter 1, sorry. The thing we were learning in chapter 1, which is there distributive property? No. Are there like terms to combine? No. Then I need to get the variable on one side and the number on the other using add and subtract. I want to get them separated, right? And so I'm going to be adding 5 to both sides to separate the numbers from the variable. So I get 18 equals 3x. And then the last step is to use multiplication and division, or division. And mostly, you guys have probably noticed it's mostly a lot of division. And so I'm going to be dividing by 3. So when the dust clears, I found out that x is 6. So 6 in here for x. And I meant in the back of the book that they just say 6 is what they say. I think they say -5, comma, 6, comma, and then what we're going to find over here. Just kind of shortcut notation for it. So here they're saying y, this is x, right? Y equals 3 times x minus 5. So I'm going to put in -2 for x. And then you notice all I have to do is the arithmetic. -6 minus 5 is -11. That's what y is equal to, -11. Okay, so we did a lovely job on that. So I'm going to keep everything on my grid. And so I notice this time my grid goes from -7 to 7 if I count by ones, and -7 to 7 if I count by ones. And so since I have something that's 13 as the biggest thing there, and I'm thinking about counting by twos. And so if you count by twos, so this is 0, 2, 4, 6, 8. You have to show it when it's something other than counting by ones. So I let us be lazy and not write. I'm not even sure that it's too lazy unless we're counting by something other. So I've decided to count by twos. And so let's see here. This is -2 and -4 and -6. So over 0, I'm plotting this point, over 0 down 5. So down 5 would be right in between -4 and 6. So I'm going to put it right there. And then 60 over 6 up 13, and I said 60, but it's 613, and 13 falls right in the middle between 12 and 14. And -2, -11, so -2 is right there, right, because counting by twos. -6, -8, -10, -12, so over -2 down 11, there's 9, here's 11. And then I'm going to whip out my ruler here, and I guess I've asked some questions, and before I get too crazy and start answering these questions, we found 3 solutions to this equation so far. So I'm going to ask you, how many solutions do you think there are altogether? And if you kind of think about how we found solutions, right, you can kind of imagine that you could find more solutions pretty easily, particularly if you picked values for x, like x is 1, would pretty easily find me another solution for y. And so all you'd have to do is put it in, right? 3 times 1 minus 5, 3 minus 5 is -2. And all of a sudden, and they help me build my solutions, but all of a sudden I have a 4th solution. So I say we found 3 solutions so far. How many do you think there are? And the answer actually is as many as you want, right? And that's infinitely many solutions. So we could name them all day. I don't want to name ones that are fractional, but I could say to you, well, if x was, let's say, half, not a hard fraction, well, I could find the value for y. It would be a matter of doing arithmetic. Now, I can also pick values for for y, like I could pick y to be half if you wanted. And that's going to be harder to find the value for y that goes with that. This one's not going to be so hard at all. It's just arithmetic. But this one's going to be solving. And so whenever I'm getting the choice on picking solutions, why would I pick something hard? I should pick something easy. And so I want to show you that a line goes through these solutions here. My pencil, I think my ink, it might be out. And so see how they're all on the same straight line there. And when they're all on the same straight line like that, they're called collinear. And so these points right here are all on the same straight line. And in fact, this extra solution that I got for us, 1, -2, so remember 1 is halfway over between 0 and 2, -2. So there it is. It's also on that line. And I expected that it would be on that line as well. Okay, so we did a lovely job on that, and it was a bonus to graph it because they didn't ask you to graph this particular question. They just asked you to fill in those 3 ordered pairs, but they do go on to giving you these and asking you to graph it. So I just went on. I couldn't help myself. I got so excited. Seemed like the right thing to do at the time. So infinitely many solutions, and all of the solutions, the infinitely many solutions, fall on this line. They're ordered pairs on this line. This line goes each way. It eventually gets every value for x. It's pretty steep, but it eventually gets every value for x. Even x is 100. It just takes y is really tall, really up there when x is 100, right? It's pretty steep line. Okay. So they asked us to complete this table. So this is another way of holding onto your ordered pairs in notation. And you just use the equation. And so my equation is y equals -5x. And so it has 2 variables in it, and it's going to give me one of those variables. So they're telling me that x is 3. So when I plug in y equals -5 times 3, so that means that y equals -15. And then that is an ordered pair. And they're telling me here now that y is 0. So that's my work. I know we could have done it in our head, but I want people to know that I did use the equation. So we're going to be putting in y is 0 equals -5x, and I want to solve for x. Distributive property, no. Like terms, no. They are separated, so no, we don't do that. So put our finger on x and divide by what we see, which is -5. You can also think about it. You don't have to solve it. You could think about it. And 0 divided by -5 is 0. So often people tell me that's undefined. And the good news is your calculator knows. So like if you get yourself thinking, is that undefined? I don't remember. Well, you could ask your calculator. If you do 0 divided by -5, what do you get? And your calculator will say 0. I get 0. So now you could have thought about it, right? -5 times what is 0? Well, -5 times 0, right? So you could definitely think about it. So here they're telling us what y is. Y equals, they're telling me what x is. -5 times x, right? So I'm going to be putting in -2 for x, they said. So y is 10. So 10 goes in here. And -20 for y. So they kind of alternated here. And so for y, I'm going to be putting in -20 equals -5x. And so you notice that when I'm having to solve for x, because of the equation being solved for y, I have to do a little bit of algebra. I'm going to divide by -5, but it doesn't turn out to be that tricky. These birds are going crazy, I tell you. So 4. And then I say, as a bonus, let's plot them. And so when we go looking at what we would count by to make it fit on there, since we have to fit -20, that's the one that's the furthest away. And so since we have to fit on there -20, if I counted by 3s, then because there's 7 dots, I would get to -21. So maybe I will count by 3s. Why not? And so let's see here. 0, 3, 6, 9, 12, right? Going that way. And I got to go down in the negatives. So -3, -6, -9, -12, -15, -18, counting by 3s is hard, -21, -21, not -20. They have to They have to go by 3. And I accidentally went by 2 there. And they have to be all equally spaced. It's okay to do on each axis has to be equal, all the spaces. Let's see, -3 over here, right? Okay, so over 3 down 15, that worked out pretty good. So over 3 down 15. Over 0 up 0 works out pretty good. Over -2, so here's -1, here's -2, here's -3. So I kind of imagine where it would be. And then up 10, so I'm going to count by 3s. 3, 6, 9, 12. And so 10 is right here. So what did we have? We were over 2, -2, up 10, 9, 10, 11, right? So right here-ish. And 4 over 4, so that's here. 4, 5, and 6, kind of equally spaced. And then -20. And so here's -19, -20. So somewhere in here. And you notice that for this line, let me get our ruler out, that the points are, again, collinear. They're on the same straight line. So once again, you draw lines long all the way across and you put arrows on them to show people that you know that they're not line segments. So I get people drawing them like this, and then I mark them wrong, and then it pisses them off and they send me a mean email. But you've drawn a line segment when you do that, and that's different than a line. You want to show that you know that the solutions go on forever. So you want to make sure that you add all the way across and an arrow onto it. That shows people that you know what that story is there. And so we did a lovely job on that. There are infinitely many points here too. And so, you know, here is another solution, and here is another solution, and here is another solution. There's 3 more solutions, and we can read those off if we want. I know that the x value of that solution is -3, and it's looking like the y value might be, this was 12 and I erased it, and 15, right? And so we might be able to estimate what that is, and we could verify with the equation what it is, right? If we put in -3, -3 should be right here at 15 on my dot. I know that, right? -3 times -5 is 15. And so it's hard to, when your pencil, right? It's almost too wide. Okay, so we did a lovely job on that, and beautiful. And that's the end of 2.2. So what they're trying to do in 2.2 is they're trying to get us to associate ordered pairs with an equation. Ordered pairs and an equation. And I couldn't help myself that since we had done ordered pairs and plotting them in the previous section, that I put that together as well. I couldn't help it. I got so excited. So that is 2.2.